Hey guys, I'm back. So let's continue talking about the different types of gas laws. So far we've covered Charles's law and Boyle's law, and hopefully you didn't have too much of a hard time working through those problems. I provided the answers for you online, so hopefully you were able to get close to it or at least have an understanding of how to do that. One of the key things that you should remember with Charles's law, you must convert those temperatures from Celsius to Kelvin first by adding 273 to each temperature. Okay. All right. So now we're going to talk about another type of gas law. And this is Gay-Lussac's law. Gay-Lussac's law is very similar to Charles's law, but it's looking at the relationship between temperature and pressure. We know that with Charles's law, we looked at temperature and volume, but in this case, the volume is actually being held constant. And so we're only looking at pressure and temperature. Now, just like in Charles's law, they're directly proportional to one another. So as you're increasing the temperature, the pressure will go up, or if you're increasing the pressure, the temperature will go up. And the opposite is also true. If you decrease one, then the other one also decreases. All right. So the formula for Gay-Lussac's looks so similar to what we've already talked about is P1 over T1 is equal to P2 over T2. And like before, P1 is your initial pressure, your T1 is the initial temperature, again in Kelvin, plus 273, excuse me. P2 is the final pressure, and then of course T2 is the final temperature, again in Kelvin, okay? You can use the same equation, cross multiply, just like we did with Charles's law, and get those answers just as easily. Very similar to Charles's law. All right, so let's take a look at this example problem. So before Molly began a car trip, she measured the air pressure in her car tires and found that it was 32 psi at 18 degrees Celsius. After 2 hours of driving, she found that the pressure had increased to 34 psi. What is the new temperature in the air? Okay, and so we know P1 over T1 is equal to P2 over T2. So let's just identify those particles or parts. P1 is 32 psi right here, and the T1 is 18 degrees Celsius. I'm going to come back and convert that. I'm just going to go through right now. P2 is 34 psi here, and T2 is the thing that we're looking for. That's the big question mark, the X in the cross multiply. So when I add 273 to the 18 here, I get 291. So that's the actual number that I'm going to work with, okay? All right, and so I'm just going to plug in my numbers into the equation that I have there. 32 over 291 is equal to 34 over T2, or my X. And so when I cross multiply, I have something that looks like this. So 291 times the 34 gives me 9894. And again, I kept to my units, K, PSI. And T2 times 32 is T2 32, or this is my X if you wanted to use that as the example. I divide both sides by the 32 so I can get the T2 by itself. And when I do that, my PSI units actually cancel out, and I plug it in and I get 310 as my final answer. I needed 2 significant digits for my final answer when I look at my pressure. Now, one of the questions that I did receive last week was that, well, the temperature is in 2 sig figs. We never use the temperature to determine the sig figs as a general rule, and I forgot to say that in the previous example. But even so, even if we were using the temperature, that would be 3 sig figs anyway, and so we still wouldn't go to that. But temperature is not really used to determine significant figures unless it's a precise temperature, like 18.0, then that's a little bit more precise, but you would still have to convert it to Kelvin anyway, okay? I have 3 problems here. Those are going to go on the left side of your notebook, like in the previous 2 types of gas laws, and same like before, the problems will be online. You can check to make sure that you have the right answers, okay? All right. Let's look at the three gas laws that we've talked about up to this point and just kind of compare them and look at the relationship. All right, to summarize, we know that Boyle's law deals with pressure and volume, as you can see right here. And we said that they were inversely proportional. That means that as one is increasing, the other is decreasing. And so that's what that relationship is talking about. The law, the rule, or the law, the equation is P1V1 is equal to P2V2. And the things that are being held constant will be the temperature. That means we don't factor it in, and N, the number of moles. Now, I haven't talked about N as yet. We will talk about that later on, but that is also being held constant, okay? With Charles's law, the things that we're looking at, the variables are volume and temperature. And they're directly proportional. So as you increase one, the other one will increase as well. We know it's V1 over T1 is equal to V2 over T2. You can cross multiply to get the answer. I think that's the easiest way to kind of think about that. And the things that are being held constant would be your pressure and, again, your number of moles. Okay, we don't factor in pressure, even if it's written in that equation. We don't factor it in because it'll say it's held constant, or there's a change between the volume or the temperature, and that's kind of the way you know that. And then the last thing is Gay-Lussac's law, and there again we're looking at pressure and temperature, and they're directly proportional. So as one is increasing, the other is also increasing. The formula here is P1 over T1 is equal to P2 over T2. Very similar to Charles, but we're replacing the volume with pressure. And so that means the volume is being held constant. Cross multiplying will solve the problem just as easily. And that's pretty much it for right now. We do have two more that we'll talk about, but that's pretty much the first three that we are covering. Now, you will have a quiz on Friday before we go on break. Woo! I know everyone is excited about break. The quiz will cover Boyle's law, Charles's law, and Gay-Lussac's law. All right, and I'll kind of mention that throughout the whole week, but that will be done on Friday. Okay. Now for your homework, this is not due until Wednesday, so don't feel stressed out about trying to get it done. Please feel free to ask questions. I will be available on Wednesday. I forgot the time. I'll post that in the chat, but I will be available to, if you have questions, just kind of jump onto the Google Meet during that time, and I'll be able to answer any questions that you may have at that time, okay? But the the magic square gas laws, and that's already uploaded, so go ahead and answer that. And I'm going to make that available on Google Classroom. So I'll send a link for you to kind of complete that. It's going to seem like it's a quiz. It is not a quiz. It is this, but it's going to count as a homework grade. So you can go on, and I'll make it a matching kind of thing. So that way you can just kind of pick whichever one is correct, and then go from there. Okay. And then of course section 10B, not the whole thing, only 4 through 8, but you must show your work. Remember to save it as a PDF when you upload that, and that should be good. All right. I'll be back with the next set of rules and laws and that sort of thing. And it's a little bit more confusing, a little tricky, but you'll get it. All right. Talk to you guys later. Bye-bye.